Hi everyone, welcome back to Tech-Bimba channel. In the last video, I talked about the re-entrant lock. In the today's video, I will dive into ReadWriteLock. Before diving into the ReadWriteLock, let's understand the problem statement. In the real world multi-threaded application, there will be a data. This data will be shared across multiple threads. There will be a set of threads. Those will be writing altogether a new record into this data. There will be a set of threads. Those will be modifying the existing record in this data. There will be a set of threads. Those will be deleting the existing record from the data. So combining all together, we can call them as a writer threads. In this image, we can see that W1 and W2 are the writer threads. On the other end, we are having a R1, R2 and a R3. These are the threads responsible for reading the data from the shared data. These won't modify, they just read the records from the data. To give a real world example, let's say we are having an e-commerce application. In this e-commerce application, we are having a catalog of an inventory. This catalog of an inventory has a different kinds of products, as you can see here. We are having a t-shirt, bag, watch, goggle, etc. To this website, there will be millions of users. Those will log in and they will browse across this catalog. So these are the reader threads. On the other end, admin is the one who is responsible for managing the catalog. He will log in and he will update the catalog. He might add the altogether a new product type. He might delete the existing product type, or he might change the existing product price too. So these are the writer threads. So here it is very important to maintain the concurrency between these reader threads and our writer threads. Otherwise, we hit with the issues like a data inconsistency. Let's say user 1 logs in and he liked this t-shirt and he's okay with the price. He's about to purchase this product. At the same time, admin logs in and he is changing the price of this product, or he might be deleting this product itself. Then user 1 is not aware of this one and he places the order. So this will lead to the data inconsistency issue and our system will behave inappropriately. So it is important to maintain the concurrency between the reader thread and the writer threads. Traditional approach to this problem is the synchronization. As you can see here, we are making read catalog and write catalog as a synchronized methods. So this solves the data inconsistency issue. Now at any one point of a time, only one thread will be able to perform either a read operation or a write operation. But this will comes up with a cost. Since we are making a read catalog also synchronized, let's say user 1 logged in and he is browsing the catalog. At the same time, let's say user 2, user 3 up to user 100 logged in and they also want to browse the catalog. But since read catalog is a synchronized, until user 1 finishes his browsing, other threads has to wait. So this will become a huge performance issue and it will become a bottleneck to our e-commerce application and we will start losing the customers. So this is the issue with a synchronized approach. So what ideal solution we want is, we want to basically allow multiple readers to read the data, since in case of a read operation, we are not modifying any data that is already present, right? They are just reading the records present in the shared data. So we should allow multiple reads at the same time. At the other side, we also need to take care of the data consistency. Okay. For that, if any write operations are performing on the shared data, then other write operations or even other read operations should be blocked. So with that, this will be solving the data inconsistency issue as well as a performance issue. So this is where ReadWriteLock comes into picture. ReadWriteLock provides the exact same solution. We will understand the ReadWriteLock. We will start with its hierarchy. ReadWriteLock is the interface present within the Java util.concurrents locks package. It has two methods, ReadLock and a WriteLock. Both methods return lock type. Re-entrant ReadWriteLock is the class that provides the implementation to ReadWriteLock. So this class has two inner classes, ReadLock and WriteLock. Both the classes implements the lock interface. So when ReadLock and WriteLock are implemented within the re-entrant read write lock, internally they will return a read lock reference and a write lock reference respectively. This is how read write lock hierarchy looks like. Let's understand the read lock and a write lock. The idea here is, in case of a read operations, we are not modifying the data. So we should be allowed to read simultaneously. That's what read lock provides us. So in case read lock is acquired by any thread, so multiple threads can also acquire the read lock. So at the same time, we can basically perform the read operation using the read lock. Use cases are like this can be used while reading the data, fetching the data, searching, and for a report generation. So all are like use cases of reading a data, right? The constraint here is, once a thread acquire the read lock, no other thread can acquire a write lock at the same time. This is the constraint. While n number of threads can acquire a read lock. Okay. Now coming to the write lock. So once any of the thread acquire the write lock, so we are not allowed to basically perform any further read operation or even a write operation. So this basically ensures the data consistency. Say suppose one thread is writing data into the shared data, so at the same time none of the threads should be able to do the write operation and even to do any read operation. So this is the use case of the write lock. So write locks are exclusive. Once the write lock is acquired by any other thread, so none of the threads can either acquire the read lock or they can acquire any write lock as well. Use cases, so whenever we are updating a data, deleting a data, inserting a data, or modifying a data, so we will go with a write lock. Let's understand this with an example. We have a catalog class. This class is being shared across reader threads and writer threads. So in this class, we can see that we have a product name and a price. At the line number 9, we are creating the instance of ReadWriteLock. We have a read catalog and a write catalog as a methods. So within read catalog, we are acquiring the read lock. We can see here lock.readLock and a lock. So we are acquiring the read lock since we are going to perform the read operation as a part of this method. On acquiring the read lock, what we are doing here is we are printing the name of the thread and we are reading the catalog. So here we are printing the product name and its price. So within finally what we are doing, we are basically releasing the lock using unlock method. In case of a write lock, at the line number 45, we can see that we are acquiring the write lock. So lock.writeLock, then we are calling the lock. So this is how we are acquiring the write lock within the write catalog method. We acquired the write lock, then we are updating the catalog. So in this case, we are adding altogether a new product and a new price to the product. Okay. At the finally block, we are unlocking the write lock by calling the unlock method. This is our main method. Okay. Here we can see that we are creating the instance of the catalog. Okay. Then we are having a reader task and a writer task. So we are having a reader 1, reader 2, reader 3 as a 3 threads. These are the reader threads. Okay. Here we can see we have given a read task as an implementation to these threads. Okay. Then we are having a one writer thread, that is W1. We are starting all these threads. So on executing this one, we can see that till writer 1 thread is updating, reader threads are waiting. So this write operation is a mutually exclusive because of the write lock. At the same time, you can see that reader 1, reader 2, reader 3 are all happening at the same time. Since all the threads are basically acquiring the read lock, right? We are allowed to acquire read lock simultaneously. Because of that, reader 1, reader 2, reader 3 are executing simultaneously, and they are able to fetch the catalog. So they are able to read the product name as iPhone and even its price. So this is how read lock and write lock works. So that's it for the today's video. If you found this video is helpful, please like, share and subscribe to the channel. In the next video, we will dive into semaphore in detail. Thanks for watching.